Welcome to your channel CodeVish. In this video, we will discuss about Kubernetes architecture. In the previous video, we discussed about container orchestration. So if you haven't checked out that video, so I would recommend you to check out that video first. So before we head into setting up a Kubernetes cluster, it is important to understand some of the basic concepts. This is to make sense of the term that we will come across while setting up a Kubernetes cluster. So let's start with nodes. A node is a machine, physical or virtual, on which Kubernetes is installed. A node is a worker machine, and this is where containers will be launched by Kubernetes. It was also known as minions in the past. So you might hear these terms used later changeably. So what if the nodes on which our application is running fails? Well, obviously your application goes down. So you need to have more than one nodes. A cluster is a set of nodes grouped together. This way, even one node fails, your application is still accessible from the other nodes. Moreover, having multiple nodes helps in sharing load as well. Now we have a cluster, but who is responsible for managing the cluster? Where is the information about members of the cluster stored? How are the nodes monitored? When a node fails, how do you move the workload of the failed node to another worker node? That's where the master comes in. The master is another node with Kubernetes installed in it and is configured as a master. The master watches over the nodes in the cluster and responsible for the actual orchestration of the containers on the worker nodes. So when you install Kubernetes on a system, you are actually installing the following components: an API server, an etcd service, a kubelet service, a container runtime, controllers, and schedulers. The API server acts as the front end for the Kubernetes. The users, management devices, command line interfaces all talk to the API server to interact with the Kubernetes cluster. Next is the etcd key store. etcd is a distributed reliable key value store used by Kubernetes to store all data used to manage the cluster. Think of it this way: when you have multiple nodes and multiple masters in your cluster, etcd stores all that information on all the nodes in the cluster in a distributed manner. etcd is responsible for implementing logs within the cluster to ensure that there are no conflicts between the master. The scheduler is responsible for distributing work or containers across multiple nodes. It looks for newly created containers and assigns them to nodes. The controllers are the brain behind orchestration. They are responsible for noticing and responding when nodes, containers, and endpoints goes down. The controllers makes decision to bring up new containers in such cases. The container runtime is the underlying software that is used to run containers. In our case, it happens to be the Docker, but there are multiple solutions available. So we have Cryo, we have Rocket. And finally, kubelet is the agent that runs on each nodes in the cluster. The agent is responsible for making sure that the containers are running on the nodes as expected. So far we saw two types of servers, master and worker, and a set of components that make up Kubernetes. But how are these components distributed across different types of server? In other words, how does one server become a master and the other slave? The worker node, or minion as it is also known, is where the containers are hosted. For example, Docker containers. And to run Docker containers on a system, we need a container runtime installed. And that's where the container runtimes falls. In this case, it happens to be the Docker. This doesn't have to be a Docker. There are other container runtime alternatives available, such as Rocket or Cryo. But throughout in our video series, we are going to use Docker as our container runtime. The master server has the Kube API server, and this is what makes it as a master. All the information gathered are stored in a kube value store on the master. The key value store is based on the popular etcd framework as we just discussed. The master also has the controller manager and the scheduler. There are other components as well, but we will stop here for now. The reason we went through this is to understand what components constitute the master and worker nodes. This will help us install and configure the right components on different systems when we set up our infrastructure. And finally, we also need to learn a little bit about one of the command line utilities known as the kube command line tool, or kubectl, or kubectl as it is also called. The kubectl tool is used to deploy and manage applications on a Kubernetes cluster, to get cluster information, get the status of nodes in the cluster, and many other things. The kubectl run command is used to deploy an application on the cluster. The kubectl cluster info command is used to view information about the cluster, and the kubectl get pod command is used to list all the nodes parts of the cluster. That's all we need to know for now, and we will be learning more commands throughout this video series. We will explore more commands with kubectl when we learn the associated concepts. For now, just remember the run cluster info and get nodes commands, and that will help us throughout the first few sessions. So thank you for watching the video. Please do like, share, subscribe the video, and also I will seek out to get some more feedback from you all to improve the course quality. So all of you are welcome. Thank you.